Today we will be speaking about migrating to the exabyte.io platform and utilizing the collaboration tools. Before we start, I'd like to make a few remarks. First of all, the goal of this seminar is to help users understand what exabyte.io is and how to benefit from using it. This is the second webinar in the monthly recurring series, where first Friday of each month we speak about getting started with the platform. And every third Friday of the month, we speak about the advanced topics. And here is the advanced topic session today. Every participant should be a registered platform user to be able to try and follow the explanation in the webinar. Every participant will receive this presentation in a PDF format after we're done, so there is no need to take notes. And this webinar is recorded and will be made available to you by email as well. If you have any questions at any point during this webinar, please ask those questions using one of the two options in Zoom, either through a chat or through the Q&A. We will go through questions at dedicated time slots during this presentation. We will assume that the webinar participants are experienced with computational material science tools like Quantum Espresso, VASP, or similar. We will assume that users understand the basics of Linux operating systems. And the user has an established set of scripts and input files that they can use to perform calculations. And our goal would be to help this user migrate the scripts and input files to be able to use those inside the Exabyte platform. For that, we will discuss two options. One option is to bypass the web interface entirely and use alternative connection methods like command line connection or remote desktop. And this is a quick and easy way to start for people who are familiar with command line. However, it is prone to error and it is difficult to reuse and share the data if we adopt this approach. The second scenario is about adopting the Exabyte platform approach, where we create materials, workflows, and calculation jobs as the platform entities. This will require us to understand the Exabyte platform approach, which has a learning curve, but once we do that, we can reuse this approach and utilize it for multiple materials, run high throughput calculations, use powerful Python-based tools, and etc. These two options mirror two options for collaborating within the platform. Users can either bypass the web interface and collaborate using the file system, or they can adopt the Exabyte platform approach, create the entities, materials, workflows, simulation jobs, and share them using team-based permissions that we establish for the accounts within the platform. And again, the pros and cons for each approach are very similar. One requires more learning than the other, but it's also more powerful in the long term. So here is the agenda for today. We will be speaking first about the platform infrastructure, alternative connection methods, and the file system, and how we can use it to share the information. Then we will speak about each of the platform entities and how to migrate existing information from an example pw.x input file to the platform. We'll first speak about materials, then workflows, then simulation jobs. And we will finish with a discussion of collaboration and team organizational accounts and sharing of the data. A quick note about the webinar account. All webinar participants can request access to the webinar account in the Exabyte platform. This account has advanced features enabled for it, like command line access, for example. And during the webinar, we will look at recorded snapshots of the functionality, and we'll look at videos, but with the webinar account, any of the future viewers will be able to follow and execute exactly equivalent actions in the platform. With that, I'd like to start and speak about the platform infrastructure. Here you can see the architecture of the exabyte platform, which contains multiple different parts. It's a distributed web application that runs in the cloud. And if you look closely to the user-facing parts of this distributed architecture, we'll see that there are a few. And number one is the web interface that users connect to using their web browsers. And it is connected further, the web interface, to the login node, which is the main connection point for people that use secure shell or command line. And the web interface supports connecting to the login node through either remote desktop or web terminal. And those will be the three that we will speak about in more details today. There is also a RESTful API as one of the connection options to work with the data, but that's a topic for a separate conversation. So secure shell connection, or SSH, is based on a key pair and requires an SSH client on the user side. It could be putty or terminal. Web-based command line terminal is equivalent to SSH and can be started from any web browser. We don't require a client in this case. There is an option to use a remote desktop connection as well through a web browser. And it provides a familiar CentOS Linux system desktop environment with tools like Vesta, Xkristen, Nanolabo, and such. And the RESTful API we will omit for today's discussion. In order to establish the SSH connection, we have to first upload the SSH key, the public key in this case. And we can do that using the Preferences tab of the account profile. If we scroll down there and click on the plus button with SSH keys, we can upload the key. There is a tutorial for that in the documentation. You can follow that on your own. The second option is to use the web terminal. And for that, we have an option inside the right-hand sidebar. So if we click on the username at the top and then select the terminal, we can open the command line terminal session from the web. This is how it works. We can upload and download the files by dragging and dropping the files into the session. And we can copy paste the data between the session and local computer by using the copy paste dialog, which can be opened by pushing 3 buttons at the same time, Control, Shift, and Command on Mac. The remote desktop is another alternative to the web terminal. It can be opened equivalently from the right-hand sidebar. And here we have a familiar Linux environment where we have the file system access to applications and the display. And if you want to close the session, we can click on the cross button in the top right corner. Now, to understand how we can collaborate using any of these alternative connection methods, we have to understand a bit more about the file system that we employ. And the file system connects the user from the login node into multiple clusters. Multiple clusters, each of which, in our case, is running on different cloud provider. So in the production, we have cluster 001 that runs on Amazon Web Services. We have cluster 007, as of right now, that runs on Microsoft Azure. We also have support for Google Cloud and Oracle, but this is still an experimental kind of support. So we endorse the usage of cluster 001, cluster 007 in production. Now, the file system that is available on each of these clusters is then shared onto the login node. And it is available for the users under their home directory or under the organizational directory that users connect into. So when we connect to the login node, we have access to all the clusters at the same time. This is how the home directory looks when we connect to the login node. We have two links to cluster 001 and 007. And these links will let us access the corresponding file system. So if we go into cluster 001, we'll see that there are certain system level folders that help us further organize the information. And you can see that as I am a member of the exabyte-io account, I can see the corresponding folder. Here, this is how I can access the data that is produced under this account. Data folder is where we store the web-based, web-originated calculation jobs. And I will explain the naming convention there in a moment. And we also have links to the Dropbox folder, which is very similar to the concept to the familiar to many Dropbox application, an application that is available in many places on the user interface side, on the computational infrastructure side, etc. And the last folder here is job script templates, which provides the batch job script templates for simulation engines like Quantum Espresso and Fast. So when we first connect to the file system, there are a few important things for us to have in mind, and Dropbox is one of them. So Dropbox is connected to the login node. It is connected to the calculation clusters, to the master node of the cluster. It is also connected to the web interface. And it is also present during the calculation time on the compute nodes. So the data that we put into the Dropbox folder, it is available everywhere on the infrastructure. And that's why it is very powerful. So we can put things like potential files or scripts that we want to run into this folder. It is not meant for any kind of big data. It should not be bulky, but it has to be something that is necessary for the calculations to proceed. Inside the data folder, we have the calculations named according to a certain convention. First, when we create the calculation from the web interface, we organize the jobs based on a specific project that they reside in. Usually, scientists work based on projects, which can last months, sometimes years. And we help them organize the calculations that hold information specific to a certain project inside the project item, which is very similar in concept to a folder. And project also have specific accounting identifiers for them so that we can track how much was spent on a particular project. Now, if we create a project, create a job for a user named Steven under his default project, named default, and we name that job according to the date when it was created, we will automatically get an ID for this job that was generated during its storage in the database. And then, according to all this information, we can set up the naming convention in the command line. So here is how the command line job will look like. It will be inside Steven-default project, and it will have the concatenated name of the job together with the identifier. And we employ a very similar convention for the jobs inside the organizational accounts, except for they're going to be stored not inside the home folder, but inside the share groups account name folder. User data folder on the cluster could be handy when we would like to use additional functionality like visualization tools on the data that is produced during the calculations. So if we know where the data is located, we can pass it to the tools like XQuestion and add additional visualization functionality, which might not be supported yet on the web application side. Here is a quick demonstration. Okay, so here is then the notes about the remote connection methods. Remote connection provides an alternative way to access the Exabyte platform. It can be enabled upon request for specific service levels. There are three options in the web terminal. Remote desktop, both can be accessed in browser, and a secure shell session. Remote connection methods allow users to connect to the login node with a separate home folder for each user, and home folders link further to compute clusters. One important note here is that command line jobs must be submitted from within a cluster directory, not any other ones inside the login home, which means that we first have to explicitly change our user session into the cluster directory, so navigate into cluster 001 before we can submit command line jobs. And that's because we have to route the jobs accordingly to one of the clusters. And by knowing where you are presently in the file system, we can understand where to send the jobs. There is a variety of software packages available both through remote desktop and through command line modules environment. Okay, let's see if we have any quick questions at this point. I do not see any. No questions yet, so let's continue and go and speak about materials. So how do we take a calculation that contains materials information and migrate this calculation, migrate the materials information first to the exabyte platform? There are a couple of options, and I will speak through two of them today. So let's assume that we have a quantum espresso calculation with two files involved. File number one is representative for a self-consistent field calculation, and file number two has non-self-consistent field calculation as the second part of the workflow. So in order to reuse the material information present here, we first need to understand the logic inside the workflow and how to take this material information out of this file. And our second step would be to understand how to extract this material information, right? So here, for example, we have the cell parameters, which tell us about the crystal lattice, right? How we can define the crystal lattice. And we also have atomic positions for the crystal bases. So now that we understand this information, and the important part here is also cell dimension 1, the lattice constant that we use to, that we need to multiply by the cell parameters to get the values in atomic units. So once we have this information, once we understand it, we need to open a materials designer session by clicking on the plus button in the list of materials. And this presents us with the materials designer interface, which holds a default material, silicon FCC, as the material that we initially have inside the left panel. What we would do here is we would clone this material and remove the default one to be able to create a new material according to our specifications. We are working there with calcium tungsten 04, and that's what I put in the name for this material template. All right, that's how we start. The second step would be to migrate the crystal lattice parameters from the input files to the current material in the session. And for that, we open the crystal lattice dialog and select triclinic as the lattice type, so that we can modify each of the lattice parameters separately. We then need to migrate the information about the lattice, and to do that, we have to calculate the lattice parameters in angstroms, because that's what we support in the user interface, which I do using Google. And it's a very convenient tool it provides, so I can put lattice parameters in angstroms for the lattice vectors A and B. And then I also multiply the lattice parameter C by the corresponding value in the input file. And then I put all the angles as 90 degrees. And as you can see, the cell is now representative of what it is inside the quantum espresso input file. All right. So that's how we set the lattice parameters by adjusting the form values and clicking Apply Edits. And then the next step is to set up the crystal basis parameters from the WSCF input. And for that, all I have to do is just to copy the coordinates because they're already in the crystal positions. I don't have to do any extra work. I'm just copying and pasting them directly into this frame, into the form. And as you can see, the atoms are now present in the visualization in the 3D view on the right. So now we have both crystal lattice and crystal basis transferred from the pw.x input file. And we can ensure that this is indeed the material that we want to work with. The next step and the final in this progression is to save this material. And for that, I can click on the input-output dialog, select save, optionally add a tag to this material, which I will call from pw.x to be able to find it easily in the future. And click save. Once the loader finishes spinning, we'll get the operation successful note in the bottom right corner. And if we exit the materials designer session now, we can see this material at the top of the list and the corresponding tags for it as well. So this is how we create a material starting from the Quantum Espresso input files. Another option for doing the same is to use a translator, something that would first convert the Quantum Espresso input file and material information inside it into postcard, which is what we support natively for the materials data upload. So once we have postcard file, we can upload it using the upload tool, which I explained a couple of weeks ago during the getting started webinar session. So the one convenient tool can be obtained online at cheminfo.org, and we can use it to migrate the Quantum Espresso inputs to postcard files that we can further upload to exabyte. Okay, so by using one of these options, we can migrate materials information from Quantum Espresso input files to exabyte entities. Now, the second step would be to migrate the logic inside the calculation workflow as well. So here we can see that the logic is fairly simple. We only have two units. One of them executes the self-consistent field calculation. The other one executes the non-self-consistent field run. And these two will represent the logic inside the workflow that we will design. And equivalently to materials, we have a workflow designer application inside the exabyte platform. And this is what we're going to use to create the workflow. To be able to do that, we will navigate to the list of workflows and click on the plus button to open the workflow designer session. Inside this session, then, we will adjust the name of the workflow. Call it new workflow from pw.SCF input. And we will adjust the name of the sub-workflow as well, called SCF and SCF sub-workflow. And as you can see, the sub-workflow panel is shown on the left, and it reflects on the name of the sub-workflow in the current session. Now, the next step after that is to add a unit to a sub-workflow. And I spoke through and explained the annotation workflow sub-workflow unit in the Getting Started webinar a couple of weeks ago. You can follow that explanation. You can find it on YouTube. But each sub-workflow can contain one or multiple units, and this is what we're going to be adding here right now. So when we click on the plus unit button at the bottom and select execution unit, append to current, and click apply, we now have a template for pw.SCF, the self-consistent field calculation, that we can further explore. So if we click on that unit, we'll see its content. We'll see that, we'll see that it has certain content. like the executable that it corresponds to, the flavor that it corresponds to, and we support multiple flavors, self-consistent field, non-self-consistent field, band structure calculation, relaxation, and so on, right? So for each of these types of calculations, we have a template that will allow us to create the corresponding unit of the workflow. Now, there's also a set of properties that we suggest that users extract from this calculation unit that include things like atomic forces, Fermi energy, total energy, pressure, and such. And these properties are correlated with the input file that we provide. Right? So we make sure that the certain flags like T-stress or TPRM4 are in fact set inside the input files, and they're paired with the corresponding flags and the properties now. We also have a set of monitors that we extract during the calculation. Like we look at the convergence of the electronic subsystem, and we look at the standard output. And as you can see at the bottom, we have the template that codes the original flags that Quantum Espresso reads during the calculation. So in order to migrate the information from the original file, we have to check and see, which flags we need to migrate or add or delete from the template. As you can see, there's 3 flags that we need to add into the control name list, which is what I'm doing here. And there's certain flags that I need to add into the system name list. And the same for the electrons name list. I have to adjust its content to match the content of the original input file, which is what I do here. Okay, so this is a bit of manual work where we have to be careful and look through the flags and make sure that the 2 sets of flags are equivalent. But once we go through that, the powerful part about having a template is that it can be rendered for any material. So instead of coding material information from the original input, like it is here, hard-coded, we keep the template variables inside the template, right? And these template variables, they can be rendered using materials information, using the information about the workflow, such as keypoint grid dimensions. And that's how we make the workflow sort of usable. So if you look at the preview tab, we can see how the input template is rendered using the template data. That includes material information as well. All right, so that's how we set up the first unit of the workflow. And our next step would be to add the second unit. So we have 2 units in the original calculation, the self-consistent field and non-self-consistent field. And for the second unit, we start with the SCF part and then change the flavor to NSCF. You can see how the set of properties that we extract from it also change correspondingly. Right, when we have SCF as a flavor, we have 1 set of properties. When we select NSCF, we have a different set. And then we repeat this procedure of copying the corresponding system flags. Right, just like for the previous unit, we make sure that these system electrons and calculation name list contain equivalent information. And instead of copying the exact keys like they are here, for example, instead of copying the cell dimension as a number, we retain the original template variables, because this approach will make this template reusable for multiple materials. All right. Okay, so once we're done, we now have 2 units inside the workflow, pw.SCF, pw.NSCF, in exact correspondence to the original set of files that we started with, right? So here are the files for NSCF and SCF calculation. And at the end of this procedure, inside Workflow Designer, we have an equivalent set of input units. The last step in this progression is to save the results in the workflow, and we can do that by first adjusting the name and adding some metadata, if these are optional steps, of course, and then clicking the Save button in the header. The button looks like check mark. Click on it, and then we are exiting to the list of workflows, which now contains the workflow that we just designed. All right. If you want to come back and view it again, we can click on its name and either edit it further or modify, change some of the parameters. Okay, so that's how we migrate the workflow logic from Quantum Espresso input files into the exabyte platform entity. Okay. The second option would be to start not from the empty workflow, which is what I just did in the first case, but start from a workflow that already extracts a similar property. For example, as more and more users join our platform, we see that more and more workflows are produced and shared in the workflows bank. And in order to navigate and see those workflows, we can select the bank workflows inside the left-hand sidebar. So if you click on the left-hand sidebar trigger, and then click on bank and workflows, we can search for a particular property like band structure. And as we can see, there is a set of workflows that support the band structure calculation today. And we can select one of them and start our calculation, start designing our workflow from this preset workflow instead. Instead of starting from scratch, we can start with the workflow that another account have already created before. We would suggest starting with a workflow created by curator's account, and you can select and search by the account name as well. So we can search for band structure and then narrow down the list of workflows to those that are created by the curator's account. And curator's account is mostly managed by the Exabyte team today. And we make sure that it contains the workflows that are of highest quality, that in fact work in the platform and can provide the best result. All right, so we would suggest starting with those. And now we can select one of the workflows, click on copy, action at the top, and then navigate back to our account list to see the workflow present for our account. Again, each account has its own set of workflows. Bank workflows contain the shared repository across all the accounts in the platform. And we can copy a workflow from bank account to our organizational or personal account to use it and build the required functionality, the required logic. All right, so this is how we create a workflow starting with Quantum Espresso input files. I do not see any questions as of this point, so I'm going to proceed and speak about the simulations, the calculation jobs. So once we have the material and the workflow, we can proceed to create simulations. We can proceed to characterize this material according to the workflow logic that we have designed. And for that, we also have a couple of different options. One option would be to bypass the user interface and use command line and batch scripts to execute the workflows. And that's the option that we covered separately in one of the getting started, in one of the advanced topic webinars before. So here we will not speak about that in details. Instead, we'll focus on how we can utilize the platform entities that we just created, the workflow and material. So step number 3, after we're done with material and workflow creation, is to navigate to the project. So navigate to the list of projects, which we can do from the account overview list, we can click on the projects tab and select default. And then inside the default project, we can click on the plus button to open the job designer. Just like with materials and workflow designer, the job designer is where we create new jobs. And as you can see, it has 3 main tabs: materials, workflow, and compute. And here we can adjust the name of the jobs. Select material. In this case, I'm going to select the material that we have just designed. Right? And select the workflow, the one that we just designed. So now I have the job designer session, which is holding inside itself the material and the workflow that we designed earlier during this webinar. The next step is to inspect the workflow and adjust its input parameters. Sometimes, more often than not, we have a set of parameters inside the original input file that we would like to adjust. And those could be set potentials. For example, sometimes I would like to upload set potentials that are not yet present inside the exabyte platform. And we can do that inside this session. Alternatively, I may need to modify the sampling parameters. For example, in this case, the sampling is set automatically to 5 by 5 by 5, which is based on the value of key points per reciprocal lattice of 2000. That's the default value that we use in the platform. And according to the size of the system, we set the corresponding automatic key point grid. But that is not the original value that we have present inside the input file. And for that reason, I'd like to adjust the key point sampling. So what I can do is I can navigate to the important settings part of the sub workflow and adjust the key point sampling in the corresponding forms. So for pw.x unit, there is the corresponding form here, which I can edit and put 4 by 4 by 4, 4 by 4 by 2. And then accordingly, I can edit the values for the pw.nscf unit as well. All right, so this will assert that the corresponding key point grids are in fact modified. All right, and I reflect on that inside the name of the job, so I know that the key point grids are in fact edited from the original default values. The next step after that is to set up the computational parameters. And for that, I need to open the compute tab. We would advise for production grade calculations to use the ordinary regular queue to start with it at least. And then for the cluster 001, we would advise to use 1 node and 18 cores as original initial setup. And then I also check the notifications here to receive notifications when the job is started, aborted, or when it's ended. Aborted is, of course, optional. You could just start and end successfully. So with this setup, I can click on the Save button in the header. Just like for the workflow and for material, we have this Save button in the top right corner. And when the job is saved, it is now available in the list of jobs for this project, and it has the pre-submission status. So the bright blue status with the P letter means it's in the pre-submission status right now. What I can do then is I can select the job inside the list. I click on 3 dots in the top right, and then click on the Run option to submit this job for the calculation in the infrastructure. Right. So what happens after that? The job is changing its status from pre-submission to submitted. And shortly after that, we receive the information from the infrastructure that this job is expected to start within 10 minutes. And if we wait a bit more, we'll see that the job is in fact started within the next 2 minutes and 22 seconds. And it switched its status from submitted to active as of present. And active jobs are shown in the orange color. Right? If we click on the name of this job, we can open the corresponding job viewer. And now, instead of just having 3 tabs like we did on the job designer, we have the results and files tab available as well. And as you can see, the currently active parts of the workflow are highlighted in orange. So the job itself is active and the corresponding sub workflow is active. We only have 1, so that's a trivial concern. But we can also see that the first unit of the workflow is presently active, and the second one didn't start yet, is yet to be started. So if we click on the currently active unit, we can see its output that is posted to the web application in the real time. So we can track things like convergence for this calculation, which is also a real-time process. And when the calculation is done, when the job is finished, the unit turns green. So we understand the logic behind the workflow execution, right? So if we exit the unit tab and come back to the units flowchart, we can see that the second unit is now active. We can click on it and see its progress. Since this is a more or less production type calculation, it will take a few minutes to complete. All right, and at the end, when the calculation is complete, you can see that both of the units are turning green, meaning that the workflow is entirely successful. All right. Now what I can do is I can view the results of the workflow, and the results are arranged by unit. So pw.SCF extracts certain kind of results, and pw.NSCF has its own corresponding tab as well. Right, if you scroll down. Now, after the results tab, we can also examine the files tab. And here we see all the files that were produced during the calculation. And we can either visualize the files or we can download them using this drop down. We can download them into a local file system. We can have files including subfolders, and we can navigate into subfolders and do the same. All right. So this is how we access the results and files of the calculation job. If we also want to see the cost for this particular calculation, we can come back to the compute tab and click on the corresponding link to view the cost for this particular job. It will take us to the cost panel and it will present us with the corresponding entry. All right. So this is how we can run a calculation using the workflow and material that we have previously migrated from Quantum Espresso input. Now, an optional step in this succession, in this progression, is to share this job with another account. As you may have noticed, I have run this job under the webinar account, and now I would like to share it with my personal account. And I can do that by selecting the share option inside the dropdown for this job. And then I can select my name in the accounts list and click on the read tool to give myself a read permission. As you can see now, my account can have the read permission. And if I close this dialog, this job is now shared, and there is a check mark, meaning that this job has given specific permissions to another account to access the job. All right. So if I navigate back to my personal account, I will be able to see this job there. I will explain how to do that in a moment, but that's the optional step for sharing the calculations. All right, let's summarize the jobs part. There are 2 ways to run calculations, either through command line or through the user interface. And the user interface approach is more convenient because it allows us to deal with multiple materials at the same time. And it also allows us to organize data in the database automatically. And it enables the collaboration so that multiple other people can see the work, they can comment on the results and exchange the information, build collective intelligence. So since most of the people use a limited number of workflows, we only require probably half a dozen workflows at any point in time. And this allows us to focus on creating the logic first and then migrate this logic to work with multiple material types. Okay. All right. Now I'd like to finish with discussion specific to the sharing and collaboration. First of all, what is important to understand about how the platform can be used is that there are two types of accounts, and each person, each user has a corresponding personal account. For example, for myself, I have a personal account for Timur, and I'm also a member of multiple organizational or team accounts, such as I'm a member of the seminar account that we use for the purpose of this online seminar, and multiple other accounts, including exabyte and .io. And I can use the platform as either my personal account member, which is trivial, or as a member of any of these accounts. So when I execute actions like creating materials, creating workflows, writing jobs, they will contribute to the corresponding collections of materials, jobs, and workflows for each of these accounts. And here is how we can change from using the personal account to using the organizational account. We need to click on the username in the top right corner, select My Accounts in the right-hand sidebar, and then select the corresponding account and let's click on its name. As you can see now, I'm using the platform under the seminar account, and I can see the entities that correspond to this account. Materials, jobs, workflows, and such. And if I want to come back to using a personal account, I can do that equivalently by selecting My Accounts and clicking on my name in the list. All right. Now, when we work with the organizational accounts, we have a notion of account members, right? For a personal account, it's trivial. They only contain a single member. For organizational accounts, we can add multiple members into it. And we can do that by navigating to the People's tab and clicking the plus button and then selecting the corresponding users in the list, right? So now I have added 3 platform users as account members for this example account. And we need to understand their permission levels. They could be either owners of this account, which them, a user in this case, is, and they could be they could be having administrative privileges, or they could be regular members, which is the case for the bottom 3. Now, to be able to allow this newly added members to access the entities that are created under the account, we need to create a team and delegate certain permission to this team. And for that, we go to the Teams tab and click plus button and create a new team. And this team has a certain set of permissions, which in this case will be a read. So it will be a read-only team. And then we can add account members into this team. So if we go to the team tab again, click on its name, click on the plus button, we can add account members into this team. And then these account members will receive the corresponding permissions onto the entities that this team holds. So the next step logically is to add entities to the team. So we can add a material or multiple. this case, I only have a single material belonging to this account, so I'm adding it here. And now what will happen is that the people that I've just added to the team will have the read permission, because that's the permission that this team has, on this material. So they will be able to see this material, they will be able to view the corresponding metadata, the structural information, and so on. And equivalently, if we do that for workflow or job, this is how we grant the read permissions to the account members. So it's a role-based, flexible permission scheme that we can apply. Now, beyond the permissions within an account, we also have different access levels for the entities themselves. And I'm going to demonstrate how that works on this example. So let's say we have multiple jobs inside a project. By default, when I'm working under a certain service level, which allows for private data, these entities are all created private, and they're not shared with anyone but the original account members. So what I can do here is to grant additional access to other accounts is I can select one entity and then select the share tool at the top, and then give access to this entity to another account directly. So I'm selecting the webinar entry here, the webinar account entry, and granting it read permissions. When I exit this dialog, I can see that this entity is now shared directly with another account. Equivalently, if I want to share this entity with all other accounts, I can select public here, which means all platform users will be able to access this entry and give a read permission to the public. You see the public access is given. And if I want to share it with anyone who has the link to this entity, then I will have to select the corresponding account here as well in the share dialog. And if I want it to be searchable on the web for search engines like Google, I can select anyone on the web. So for a calculation that you want to share with everybody, we can select this anyone on the web scenario so that people can find it. If you want to share it with someone who is not yet on the Exabyte platform, we can use the second option. If you want to share it with everybody who is on the platform today, we'll use the third option. And then if you want to share it directly with another account, the fourth option is what we would use. All right, now, as we can see, the corresponding access level matrix is shown for all the entities in the corresponding entity lists. And if you'd like to see the entities that are shared with this account or the entities that are shared publicly, we can navigate to the corresponding links inside the left-hand sidebar, which I'm going to demonstrate right now. So if I navigate to the shared with me tab inside the left-hand sidebar, I can see this shared with another account item, which was created by Timur, so by me as a personal user, and is now shared with the webinar account directly. All right, here's another quick reminder. Select an entry in the list, click share, select a specific account that you want to share it with, give them read permission, and then we can see that these accounts, these two entities, this entity, the entity that we've been working with, the silicon FCC material, is shared with another account and also with anyone who has the link. So just another way to demonstrate the same functionality. We click on share with me, click on the jobs, and here is how we can see the job that they've shared between the seminar account and my personal account. Now, the list of jobs that are available publicly can be accessed in a very similar way. We select the Shared Publicly tab in the left-hand sidebar. and navigate to the list of jobs. We prioritize the job lists at the top, job sets. So those look like folders. So we may need to adjust the number of entries in the page. If we do that, then we can see the currently active calculations publicly shared within the platform. So you can see what happens in the platform, which jobs, which materials are being created, and that's a way to see and stay on top of the publicly available activity. Okay. The last point here that I wanted to mention about the access levels and sharing the information about the entities is that we can add a description to all the entities that we work with, materials, jobs, workflows. And to do that, we can navigate into the entity page and click on this information icon. When we do that, we are presented with a dialog where we can write a description. And the description can be written in Markdown language, so we can have things like headers and code blocks and links. So we can have like a quick one-paragraph explanation, either for ourselves in the future or for our colleagues, so they can quickly understand what happened inside this calculation or what type of logic we deploy inside a particular workflow. Okay, this is how we attach a description. And when we look at the corresponding item in the list of jobs, we can see the description as well. So it's a plain text description available from the list of the jobs, so we can quickly pick up and see this information. All right. The final point about the sharing is that I quickly surfaced the workflows bank when explaining how we can start designing a workflow in the platform. And the workflows bank is a concept which contains all the unique workflows that were created in the platform. And an equivalent concept we also apply for materials. So all unique structures that are created in the platform are aggregated inside the materials bank. So entity banks contain uniquely created entities within the platform. And for the accounts with the private data enabled, no other accounts can access the entry inside the materials bank for the conservation of intellectual property, for the privacy concerns. To alleviate those, this is the approach that we use, unless an exactly equivalent entity was created by the account independently. So if we, by some coincidence, have two accounts that have created exactly the same material, then they would be both able to have access to this entity if they do that independently. But when the second account comes to view the bank items and they don't have an equivalent material created, they won't be able to see the entry because the first account has the private data enabled for it. And alternatively, when the private data option is not enabled, all other accounts will be able to access the entries in materials bank and the workflows bank. So this could be a convenient option for sharing the data between multiple accounts within the platform and publishing, giving high quality information to other users to disseminate the knowledge. Okay, so here's a quick summary about the accounts. The entities can be shared within one account and only that account for a secure and safe collaboration. Account teams have different permission schemes and allow members to perform actions on the entities according to these permissions. Sharing between individual accounts is possible. Sharing within the platform users, with all the platform users at the same time, as we call it, public, is possible. It's possible to share an entity with non-registered users and also make it searchable on the web. Entities support metadata like tags and descriptions to be able to add additional information and explain what happens to your colleagues when you collaborate on them. And unique entities are consolidated inside the entity banks to track unique entities inside them. All right. Okay, I think that's it with the content that I have for today. I'm a little bit over time, but let's see if we have any questions, maybe any quick questions that we can go through. All right, I'm checking the chat. No, nothing in the chat. Nothing in the Q&A as well. All right. Well, if you do have questions, please contact me directly. I'm available at Timur@exabyte.io. And you will receive the video of this presentation and the corresponding presentation PDF as a follow-up. And with that, I'd like to thank you very much. And please stay safe and well. We'll see each other in about 2 weeks during the Getting Started webinar series.